So let's take a look. It says in the diagram, O is the center of the circle. Guys, always establish where your center is. It dictates a lot of relationships. And P, Q, S, and R are points on the circle. Just saying that those points lie on the circumference. Then it gives us that PQ is equal to QS. Guys, remember, if you have equal chords, very, very important, equal chords, subtend equal angles on the circumference. Okay, very, very, very important. And they say that angle QRS is equal to Y. We're given this angle Y over here. Okay. Lastly, it says the tangent at P. Hold up. When you see tangent, guys, you should know immediately that tan chord theorem applies. So that angle is equal to this angle over here on the circumference, tan chord theorem. Okay. Very, very, very important. And the tangent at P meets SQ produced at T. Okay. So, guys, like I say, interact with your diagram first. So, we've established that P3 is equal to S1. Why? Because of tan chord theorem. But looky over here. If we have a triangle like we do over here, this PSQ, that triangle, okay? It is isosceles, which means that the base angles are also equal in that triangle. Okay, very important. Last thing that we can say, guys, angle at the center is equal to twice the angle at the circumference. So we know that this angle over here is 2y. Okay, very important. So let's have a look, see at our questions. Give a reason why P2 is equal to y. Okay, so if we look over here, P2 is this angle over here, and y is this angle that was given to us over there. Okay, if we have a circle and we have a chord sitting over here and it subtends an angle over there and it subtends another angle over there, okay, you know that those angles are equal, and the reason is angles in same segment. Okay, remember, when you get this funny little bow tie shape, angles in same segment. Okay, next question. It says, prove that PQ bisects TPS. Okay, so TPS is this whole angle over here. And we're trying to prove that PQ bisects this, which means we're trying to prove that P2 is equal to P3. We've already done that on our diagram, you just need to remember why. So let's start with P2. We said that P2 was equal to S1. Why? Because it's an isosceles triangle. So P2 is equal to angle S1. You can say isosceles triangle, or you can say angles opposite equal sides. Alrighty. Then we said over here, P3 is also equal to S1, and that was tan chord theorem. Remember, guys, if you have a chord happening like that over there, and then you have a tangent at that area, this angle between the tangent and the chord is equal to the angle that the chord subtends on the circumference. Some of you guys call that your kite surfer. Okay, tan chord theorem. So P3 is equal to S1. Tan chord theorem. Okay. Now, guys, if you find that something is equal to S1 and then another thing is equal to S1, it's the same as me saying, okay, if I make some tea and that tea is herbal, and then I make some other tea and the tea is the same kind of herbal, those two teas were exactly the same thing. Okay, so if I found that P2 is equal to S1 and P3 is equal to S1, P2 and 3 are equal to each other. That's how it works. Okay, so if we look here, therefore P3 is equal to P2. Okay, how does that prove that it's bisected? Well, if these two angles here are equal to each other, it means that that whole angle is equal to twice of them, which means that that angle is being bisected by that line PQ. So And we can say, therefore, PQ bisects TPS. That last line is probably not even necessary, but it shows that you're answering the question, okay? If you prove that those two angles are equal, you've proved that bisected angle, okay? So make sure you prove that if you're bisecting an angle, the two angles that make up that angle are equal to each other. Then it says determine POQ in terms of y. POQ. Where is POQ? Ah, we've already found it. It is this angle at the center. Okay, so guys, I didn't quite go into that. Remember, if you have a chord that bisects or subtends an angle at the center, okay, and then it subtends another angle at the circumference, remember that this angle is 2 times as large as that angle, okay? But in this circle, we've got this chord here subtending this angle y, okay? And then we've got another chord of absolutely equal length subtending this angle at the circle, at the center, okay? So here, you would first have to say that PQ and QS are equal chords. PQ and QS are equal. Therefore, they subtend equal angles at the circumference. Okay? Therefore, you can say that angle POQ is equal to 2y because of angle at center is equal to twice the angle at the circumference. Okay, so hopefully you guys understand this. In our diagram here, okay, let me get rid of all these examples. In our diagram, we've got chord QS subtending the angle y. Okay, this is QS. Then we have another chord PQ, which we've been told is equal to QS. And that is the one that subtends at the center. Okay, so if we were to theorize and say that this chord subtends that angle over there, it would automatically be y, because these equal chords subtend equal angles. So now, this angle at the center is automatically twice the angle at the circumference that it subtends. They're looking for you to understand that the equal chords subtend equal angles. And therefore, you can translate it into that angle at the center, this 2y over there. Okay. Let's take a look at the next question. It says, prove that PT is a tangent to the circle, excuse our spelling, that passes through points P, O, and A. Okay, this is where they tell you to use your imagination. Okay, so if I get a circle going, the circle that goes through P, O, and A, okay, so you need to imagine that there's this circle over here. It goes through points P, O, and A. And now you're trying to prove that this line PT is also a tangent to that circle. Okay, so how do we do that? Okay, well, we need to prove that, okay, you guys agree with me, this is a chord on that imaginary circle. So if I can prove that this angle between this supposed tangent and the chord is equal to the angle the chord subtends on the circumference, which is this 2y, I can prove that it is a tangent. So P2 and P3 we have already proved, have we not? P2 is equal to P3. So P2 is equal to P3. Proven. Okay, how does that help us? If we look over here, P2 and P3 are equal to each other, okay? And if we look over here, we've proved that one of those is equal to y, okay? P2 is equal to y. Is equal to y. We have proven that. Therefore, P2 plus P3 is equal to 2y because they are equal to each other. Okay, so if we go back to our diagram, we take a look. This angle here we've proven is 2y. This angle between the tangent, or the tangent that we're trying to prove is a tangent, and the chord is equal to the angle on the circumference. So we can say, therefore, P2 plus P3 is equal to angle POQ, because they are both equal to 2y. And therefore, PT is a tangent. But guys, you must give a reason. Remember, we've gone backwards with the tan chord theorem, so it is the converse tan chord theorem. Okay. And lastly, it says, prove that OAP is equal to 90 degrees. Okay, so guys, I'm running out of time for this question, but OAP, where does this sit? OAP is this angle over here. Okay, so what you could do, guys, is you could start proving other relationships. So if you look over here, in our big circle, I hope you agree this is a radius, okay? And that means that this angle here is 90 degrees because a tangent is always perpendicular to the radius, okay? So if you prove that, you can start proving relationships in and among here, and you will eventually get to this being 90 degrees. Otherwise, guys, if you can prove that this is a diameter, we can say that PO is a diameter. Why? Because we proved that this here is a tangent to that smaller circle. Tangent perpendicular to diameter. Okay? So, if we can prove that that is a diameter, which we've just done, we can therefore say that this diameter subtends a 90 degrees on the circumference. Therefore, OAP is equal to 90 degrees. Why? Because of angle in a semicircle. Okay, so guys, when you get a question like this, if they ask you to prove that something is a tangent, try and prove the converse tan chord theorem. If you can prove that those two angles are equal. Remember, tan chord theorem says tangent has an angle, it is equal to the one that the chord subtends, okay? Because of that tangent, those two are equal. If you're trying to prove a tangent, you go backwards. You say, okay, these two are equal, therefore this line is a tangent. Okay, you go backwards. When you use the converse, you go backwards. Okay.